So good morning or good afternoon, everyone, depending on where you are. Welcome to our webinar that we have here at GoodWe. My name is Theodoric Leao, and with us we also have Jonas here, and we will present some topics from our portfolio. So firstly, we will go through a little bit about our residential portfolio and what we can offer there, especially focused on the storage inverter that we have. And then then Jonas will present a little bit about our safety functions and some new features that we have on our inverters. Okay, so let's start. Yes, here you see the sort of agenda for today. So first, shortly about our GoodWe residential family, then about the safety of PV plants, and then GoodWe solutions. So let me present our residential families here. So if we look at our portfolio, it's very broad, and especially in our residential portfolio, we have many different inverters. Here you see the residential portfolio, and these are then all the main residential inverters that we have. If we look at the first two ones, we have our single phase inverters, so the XS series and the DNS. The XS is the smallest one we have, and it ranges from 700 watt up to 3 kilowatt. It's very compact and very light. You can sort of even fit it in your backpack. And it comes with 1 MPPT. If you want to have 2 MPPTs instead on a single phase inverter, we do offer the DNS inverter, which has 2 MPPTs. This is still a single phase inverter, and it's sort of take over from the XS series. So after 3 kilowatt, it goes from 3 kilowatt up to 6 kilowatt. Yes. And also good to mention is that all of our single phase portfolio is completely cooled without any fans. So they're very, very silent, perfect for residential installations. And now if we look at the 3-phase residential inverter we have, here we actually only have 1 PV inverter, and this is the SDT G2 series. This ranges from 4 up to 15 kilowatt. Also offers 2 MPPTs, but different amount of string inputs depending on which power class you have. It's also very compact and up to 6 kilowatt, same as the DNS. Then it's completely cooled without fans, and then from 8 kilowatt and upwards, then it's cooled with smart fan technology that we have. Apart from the very good efficiency that these inverters offers, they also come with several different communication standards. We offer Wi-Fi communication, communication with straight wires, so LAN or RS485. If you live in a remote area, we also offer 4G connection. So directly with a SIM card, you can connect to the internet and then still monitor your plant through that. So these are the PV inverters we have. So these are pure PV inverters, and they work very well. However, if you want to have if you want to have storage inverters, then we offer basically 2 different types of inverter technologies. So first, we have the hybrid inverter, and to explain the concept of our hybrid inverter, we have this picture here. So this is basically an on-grid inverter with battery. So here you see the inverter and the different connections. So exactly like a normal PV inverter, you have the PV modules connected here with DC, and then you have some AC power going out here where you connect the loads, or you have the excess energy exported to the grid. Something different with our hybrid inverter is that they also offer in addition to the PV modules that you can connect here, you can also connect the battery. So here you can both get energy and store energy into this lithium-ion battery. But we also offer a backup port to this to these inverters. So you basically have 2 AC outputs, one that goes directly to the grid where you connect your normal loads, but also a second AC output where you can connect some backup loads. And important to mention is that when the grid is active, there's no difference between those two loads. They are powered equally from the PV modules, the battery, and from the grid. So there's really no difference between those. However, the difference is when there is a grid outage. If you have a grid outage, this side here will disconnect because of regulations and for safety, the inverter is then not allowed to feed out any power on the same line that's connected to the grid. Instead, you have the backup power here, which will keep on working. So internally, every switch and so on is internal. And because it's internal, you have a backup switch time of 10 milliseconds. So it's very quick. You won't even notice it. It switches as quick as I'm switching my slides in this presentation. Yes, and so this is the concept of the hybrid inverter. And for the hybrid inverter, we offer several different inverters that have this function. They all work in the same way. The difference, however, is basically here if they are single phase or three phase. So here the first 4 inverters you see here, they're all single phase inverters who offer the same concept, the same features basically. And they come in different power classes and with different MPPTs and the sort of discharge and charge powers. Apart from that, we also have another difference between these inverters, and it's the battery compatibility that they have. So here, the first 3 ones, the EM, the ES, the ESA, they are all compatible with low voltage batteries. The EH and the ET, they are compatible with high voltage batteries instead, and maybe the most powerful hybrid inverter we have is this 3-phase inverter up to 10 kilowatt, between 5 up to 10 kilowatt, and it has 2 MPPTs. You can even connect it in parallel with this combination box, so to say. Yes, and something other to mention is that the whole hybrid residential portfolio that we have, they're all cooled without any fans. So they're very quiet and very suitable for residential installations. If we now look at the battery inverter, this is the other type of storage inverter that we offer. And this is like a retrofit solution. So shortly to explain the concept here, if you think away this red box here, so first off, we have what we have here on the right side. So here we have a inverter. This could be a GoodWe inverter. It could also be a third-party inverter. You have the PV connected and you connect it to the AC line. And here are your loads as well, also connected to the AC line. So this is your already set system. And let's say that a few years ago you installed this PV system. At this moment, maybe you didn't want to have a storage, but now a few years later, you think, oh, now I really want to have a storage, but instead of swapping this inverter to a hybrid inverter that we saw before, it's possible to use our battery inverter concept. This is an AC retrofit solution. So this is basically, it looks similar to our hybrid inverters, but they don't have any input for PV. So it's a pure battery inverter that connects here on the AC side, takes the AC power here, charge the battery, and then back and forth. So in this way, you can utilize the energy produced by the PV here, charge the battery, and then output it again on the AC line. Exactly like with our ET inverter or with our hybrid inverters, we also have a backup port here. So you see that we have a separate AC output, and this works in exactly the same way as it did with the hybrid inverters. So here you can also connect some backup loads in case the grid fails. This connection here will then be disconnected from the grid, and then instead you can power these loads with the help of your battery. And for our AC coupled series, so our battery inverters here, our portfolio is a little bit slimmer. So here we have basically 3 different ones. We have the SPP, which is a single phase inverter compatible with low voltage batteries, so 48 volts batteries. Then we have the BH series. This is between 3 up to 6 kilowatt. Also single phase, but instead is compatible with high voltage batteries. And the last one, the BT, this is sort of like the sibling of the ET that you saw before here. And this goes between 5 up to 10 kilowatt, is a 3-phase inverter and also compatible with high voltage batteries. Exactly like the ET, this is also possible to connect in parallel with this same combination box that I mentioned before. Also good to know is that the backup power of these inverters, sure, there are some limitations. You cannot connect too big of a load because the inverter can only power so much. You're also not allowed to connect any loads with high inrush currents or any inductive loads. But as you see here, the maximum capacity you can connect on the backup side is the same as the rated power of the inverter. So a 6 kilowatt BH inverter can have 6 kilowatt on the backup side connected. Apart from that, all inverters also have a IP65 minimum rating, and some of them, like the BH, the BT, and the EH and BT series, they have even IP66 rating. Lastly, I want to present shortly our different battery solutions. As I told you before, our storage inverters, they're compatible with low voltage or high voltage batteries. Of course, we're compatible with all the major battery brands, like any third-party battery brands. But from now on, we also, or from a while ago, we also have launched our own battery series. And here we have the Lynx Home U and the Lynx Home F series. So the U is for the low voltage and the F is for the high voltage. The Lynx Home U, they come in 5.4 kilowatt hours per sort of battery stack like this. And you can connect up to 6 of those in parallel, which means that you can have a maximum storage capacity of 32 kilowatt hours. If we instead look at the Lynx Home F series, this is a high voltage battery, so compatible with all 3-phase inverters that we have. And this is like a tower solution. So here, let me get the pen. So here on the top, you have sort of the PCU, so the computer of the battery. And here on the bottom, you have each of these are battery modules. So what I was saying was that apart from, or the benefits of having a GoodWe battery with the GoodWe inverter is not only to have the same manufacturer of the battery and the inverter. So if you would have an issue, then you know who you can contact. But the very good thing is that these batteries are sort of optimized to communicate with our inverters. So all of the communications go through the inverter. There's no extra commissioning or setup of the battery itself, but the inverter will recognize the battery and sort of commission it automatically. I could also mention that we use the LFP technology. So it's one of the most safe battery technologies out there. It makes them slightly bigger, but safety always comes first. And in a residential application, a few centimeters in any direction doesn't really make a big difference. Okay, so I think this was it from me. And now Jonas will take over and talk a little bit about safety of our PV plants. So stop sharing my screen, Jonas, and you can share.
I will share my screen.
Yes.
Okay. So good morning, everyone. My name is Jonas. I come from Solar Academy, and now I'm in GoodWe Suzhou in HQ. So good morning, everyone. Today I will talk about the safety of PV plants. As we all know, safety is is a key of every plants. And now millions of households around the world install PV systems, and some of them systems are being involved in emergency cases, and which are caused by the system itself or their environment, such as fire, lightning, cable damage, and so on. And I think there are two main issues that we always concern about is that how to prevent this accident and how to handle these cases. In this presentation, so today I will show how GoodWe solutions prevent unexpected accidents and handle these emergency cases. So these emergency cases will include the condition like fire hazards and the lightning, the storm, emergency absence, like now the COVID-19, so many people can't go on site, and extreme climates, such as extreme hot weather, extreme cold weather. As we all know, the temperature could affect power generation of the inverter, also the PV models. So today I will talk about how the inverter reflect these emergency cases. So in over the past few years, there have been many media reports linking the PV system with fire. And until now, there are already nearly 200 gigawatt PV system are now installed all over the world. And increase in incidents report is to be expected. And these fire incidents have marked impact on people and property. It's very important for us to understand the likely mechanisms of ignition in PV systems. So the potential causes of fire hazards here today present could be the electrical arcing and the residual current. And so on. We know there are so many reasons that could cause fires. For example, very hot temperature and the improper installation and so on. The first topic I want to talk about is about the arc fault. In the discussion about the arc fault in the PV system, the DC side is always a focus, because AC voltage, it turns around always, and it goes through the 0 points 100 times per second. So the arc, it will extinguish itself. But DC, on the DC side, it always remains at a continuous voltage. And if there's a damaged cable or incorrectly connector contacts, and if the plug's not fully engaged, in this condition, so the high voltage could hit through the air and cause fire. Once the arc has been established, so it tends to support its continuation because of the continuous high voltage. And this likely cause of arcing in a PV system, it could cause a fire. And the most here is the most likely parts that could cause arcing, the arc fault, like the connectors and the damaged cable. Also, in a battery, between the connection between the battery and the inverter, there could be arc fault. And we all know recently there are some news that reports the battery ignition. So it is very important to identify the arc fault on these parts. So here, this picture shows how GoodWe solution identify the arc fault and how it can prevent the arc fault. So based on the sounds of tests carried on site, the GoodWe arc detection and protection solution, it adopts a machine learning technology. As we know that if there is an arc, the characteristic curve of the current, it will be something different with a normal current. Although it doesn't affect the power generation, but it's a little different. So if we write the identify software in our we call it the FCI module, then it can identify the arc fault with the arc detection, the ARM chip, in the ARM chip. And when an arc fault, it can determine whenever there is an occurrence of abnormal arcing current, and the protective measures in consequence are triggered and taken automatically. It's like to say, if we detect the detect the arc fault, it will cut off the AC relay of the inverter, both on the PV module side and the battery side. So, and at this time, there's no current on there's no current flow on the DC side. So the arc fault will be cleared. And this time will only within 0.5 seconds. So it's very safe. Let's see, this is operation page on our configuration tool. It is called SolarGo. So it's for the configuration for our on-grid inverter. On this page, we have three buttons. One is FCI detection. We can close or switch on or off the FCI function. And once we get the message that there is FCI alarm, we can clear it automatically. We can clear it here manually. So sometimes we know there could be some false alarm, not 100% every time the arc fault occurs. So sometimes we need to clear the FCI alarms, or in the condition that if you fix the issues on site, for example, you change the cable and so on, you can click here, clear FCI alarm, then the inverter could start again. Otherwise, it will be off grid. And the third button here, self-check, you can click it to check if the FCI function is normal or abnormal, or if this inverter has a FCI function or not. So this is what the GoodWe FCI solution works. And this is performance of GoodWe FCI. So there's three value that shows the performance of the FCI function. The first, it is called the trip time. So now there are some regulation that states the FCI. The earliest country that regulate the FCI is America. So this regulation called the UL 1699B. And in this regulation, it says that the trip time should less than 2.5 seconds, and the GoodWe solution is less than 0.5 seconds. And the trip energy, so the GoodWe solution has the 65 joule compared to the 750 joule in the UL requirement. And the detection distance of the residential scenario, it can detect the distance till 80 meters. And I think this is enough for the residential scenario. And this is also wrote in the UL requirements. And for the FCI, the GoodWe is always developing, upgrading the software. No, we have our the current inverter, we are always using our second generation FCI. And in this year, I didn't write here, but we have the plan to upgrade it again in this year. Like we call it the FCI third generation, but perhaps in the plan is in Q3 or Q4 this year. And that time you will know that all the parameters or performance will be improved, like the detection distance to be over 200 meters, so and so on. And another reason that could cause fire is the residual current. Sometimes the fires caused by the ground fault currents should also be prevented at a very early stage. And it's very critical in an agricultural environment. In a dusty and humid environment, the insulation failure between the line conductor and the ground may cause a low intensity arc fault according to the line conductor withstand, but high enough to cause a fire. Some tests have shown that even force current with 300 milliampere can induce a real risk of fire. However, this type of fault current is too low to be detected by our current protection. So we suggest that for the residential scenario, that an external type B residential current device to be installed. And inside of the GoodWe inverter, we integrate a type B RCMU that could detect the residual current which below 300 milliampere. Okay, and there's also some standards that make it mandatory to install RCDs of sensitivity less than 300 milliampere in locations with high risks of fire, like in Netherlands, like the primarily made of flammable construction materials in a bar or in wooden cabins containing a replaceable goods or good values in the installations. In these places, even if it's not residential, also for the CNI and so on, you need to install an RCD of 300 milliampere. But now we are talking about residential. So our inverters, I suggest that for this scenario, we should install an external RCD type A or type B. So in this year, I think in Europe, in the solar, we also showed that our BIPV products, the Sunshine series with 19.2 watts. No, this is for the roof materials. The roof materials are classified regarding the fire. It's classified into several classes, where the highest degree of fire resistance is designated class A, and lower for B, and C lower yet. And thanks to the double 3.2 millimeter temperate glasses structure, our Sunshine tile by GoodWe PVBM, the department, PVBM is our one sub department, and is tested and classified as class A in fire resistance tests, making the integration of clean PV energy into building without missing fire safety reality. So, okay. And this is the solutions regarding the fire. And sometimes in like some regions, storm lighting is also very normal. The installations of PV plants that arise from their exposed nature and collection areas makes them vulnerable to overvoltage surges from lightning. And in a lightning prone area, the lightning-induced area failures can be more detrimental to solar equipment. And SPDs are particularly critical to protect against damage from surges, including direct lightning strokes and indirect lightning. What could we do in this year is that we increase the SPD level of our residential family. So before, if you check our old data sheet of all our residential inverters, we all have only type 3 regarding the SPD, right? Okay, and if you look at our old data sheet of our residential inverters, it always has only the SPD3 for the residential inverters, like our XS, DNS series, and 3-phase STDG2 series. SPD3 is always the standard for our residential inverters. Start from last year, we upgrade the SPD level to all the residential inverters. We add the type 2 option type 2 SPD. And another function that we added for the inverter is that SPD photo alarm. That means you can monitoring the SPD, the status of the SPD remotely. If there is lightning that hit the SPD, if it is damaged, then there will be alarm. Okay, and can choose to change the inverter or change the inbuilt board, SPD board inside the inverter. Okay, and like I just mentioned, that if the environment could affect the inverter and the PV module, if the environmental temperature, just example, becomes very high, the inverter are likely to start losing efficiency. It's like the over temperature protection. No, if the temperature is very high, the inverter will start derating. That is a self-protection mechanism. So Well, the cold temperature, it shouldn't negatively impact the power generation, but very cold weather, it could affect the performance of the internal components. So the first information of GoodWe inverter is that it has a very wide operation temperature between minus 30 degree and 60 degree. We could cover most regions of the world. And another information is that thanks to the good internal space and the heat dissipation design, we can dissipate the heat field at very high temperatures and maintain a high power generation. For the residential series, like our MS and STT G2 series, the inverter can operate till 40 degree without power derating. Well, today's topic is mainly about the residential, but for the CNI series, like this value could be increased to 45 degree, even 50 degrees. So for some regions like in Africa or in some Asian regions, it's a very good characteristic. Okay, so like I just talked about in the beginning, now we are all facing the COVID-19. So I think the situation is now better in Europe. In China, it's some region we still can't go out. So, and the COVID-19 pandemic has greatly affected the people traveling, including the maintenance staff in PV industry. So in some expected solutions, we need to turn off the inverter to protect the PV system and or control or change some parameters and so on. But what to do if there is no one on site? So the first function we can realize is that the on-off switch can be deployed in a remote place where the operator can turn on or off the switch at a safe distance to control the inverter. And the communication cables such as RS485 is to connect the inverter and switch to transmit signals for a remote shutdown. Similar to the principle of the remote shutdown, the GoodWe monitoring platform SAMS Portal, it is a totally free platform for the customer to monitoring the whole PV plants. It integrates the function of the shutdown and some control function. And with one click on the website, the GoodWe cloud server will send a signal to the inverter through the via the communication tools and then shut down the inverter on the AC side in minutes. Or you can also send some control signals to the inverters via the cloud. And now the very hot world, just like in Australia and Europe, the visual power plants, we also have some projects in this region just using the control function in our SAMS portal that a third party could use API to get access to our SAMS portal and then send some control commands to our inverters. So, and that's all for today. So thank you for listening. If you have any questions, please let me know. And later, I think we could send this presentation to the cloud and you can get it. Okay, thank you all. Have a good day.